So this video is just a very quick video to remind you of some basics for graphing. And of course, this is our coordinate plane, and we have our horizontal x-axis and a vertical y-axis. Quadrant number 1, and in quadrant number 1, the x's are all positive and the y's are all positive. In quadrant 2, negative x's, positive y's. Quadrant 3, negative x's, negative y's. Quadrant 4, positive x's, negative y's. Now, the whole idea of 1, 2, 3, and 4, the quadrants, are going to very much come into play when we get into chapter 4 and start trigonometry. So, 4 quadrants, 2 axes. Now, something that I do not want us to lose sight of is the fact that we can always use XY charts in order to graph most anything, whether it's a function or whether it's not a function. So we've got a little absolute value function here, and we are going to graph it. And we'll do that with the help of an XY chart. So if we have y equals the absolute value of x plus 1 minus 3, we can first of all deduce here that the domain of this function is all real numbers. There are no limitations on what I can plug in for x. So I'm going to choose the first one by taking this expression and setting it equal to 0. And when I do that, that's actually going to give me my horizontal shift. Minus 1, x equals negative 1. So when x equals negative 1, I get 0 in the absolute value bars. And of course, the absolute value of 0 is 0, and 0 minus 3 is negative 3. Let's keep going. Let's plug in, we'll allow x to equal 0, of course, because this is going to give us a y-intercept, which is a critical point. So 0 plus 1 is 1. The absolute value of 1 is 1. 1 minus 3 is negative 2. If we plug in positive 1, let's check it out. So 1 plus 1 is 2. Absolute value of 2 is 2. 2 minus 3 is negative 1. Let's go one more in the positive direction. Let's plug in 2. 2 plus 1 is 3. The absolute value of 3 is 3. 3 minus 3 is 0. This is great. This is an x-intercept. And let's go one more. 3. 3 plus 1 is 4. The absolute value of 4 is 4. 4 minus 3 is 1. 1, 2, 3, 4, 5. We've got 5 points here. And you should know from Algebra 2 that an absolute value function is going to have an axis of symmetry. And I think we'll be able to see it happening. If not, we can plot more points. So back 1, down 3. 1, 2, 1, 2, 3. Over 0, down 2. And then over 1, down 1. Over 2, up 0. Over 3, up 1. So, we can't see anything symmetrical happen. So what that means, and as I already knew, is that this particular point, the point where x plus 1 equals 0, this is where the axis of symmetry is actually going to go through. So what that means is if I plug in a negative 2, which we can totally do that, so we'll squeeze it on the bottom of the paper here. Negative 2. Negative 2 plus 1 is negative 1. The absolute value of negative 1 is 1. And 1 minus 3 is negative 2. So back 2, down 1. That is just showing you that we do have symmetric points on either side of that axis of symmetry. So 2 in that direction, 2 in that direction, here. And this is our graph. And all we did was just use the whole idea of input values, the independent variable going into the function, giving us output values or range values or dependent values, and that is our graph. So just a reminder that we can graph anything using an XY chart. And it's never a bad idea if you don't have any idea where to start. So the next thing in section 1.1 is just the whole idea of finding intercepts. And intercepts on a graph are also known as critical points or critical values. And in this case, we have an x-intercept at -3. So an x-intercept at -3, 0. We have a y-intercept at 0, 6. So intercepts are points that we'll find, and they give us specific information relative to the context of the graph. So this is kind of a crazy looking roller coaster graph, and it doesn't just have one x-intercept, it has 3, 1, 2, 3, which means that this would be a third-degree polynomial if we were to start trying to find out the actual function that would make this graph. We have one y-intercept. So our x-intercepts would be, and we can list them as points, or in this case, I'll give them in a roster notation, -2, 3, and 6. So x-intercepts, and then of course our y-intercept, there's only one, and it's at 4 in the roster notation. So we can write them as points, or we can write them in a roster notation. But that's pretty much the basics in section 1.1.